Hello everyone, we are from Group ATT. So this is our overall layout of the robot. This robot is driven by two DC motors in the back. As you can see, it's connected to a battery. Another battery will be used to power up the MyRio, which is located in the middle of the chassis. And the front members will be lifted up by two servo motors, as you can see, located on the left and the right of the robot. So the robot will start like this. It will be the front part of the robot will be lifted up, and as the robot goes upstairs, it will move down the robot. So yeah, this is our robot Sisyphus.
Wheel inserts for the skateboard wheels to fit them on the motor. And this fits over a worm gear, which set screw will actually be on that. We also made wheel inserts for the skateboard wheels with bearings so they can spin nicely. This would be a middle pin. This would be part of the front pin. This front pin actually goes into this piece right here, which hooks to a control arm. Okay, so we have the control arm, which is actually a copper pipe, which we can put a spring into, which will actually hook to this male part of it, and this will put tension on the wheels, which actually put tension on the chains. So when this moves up and down, there should always be tension on the tank tracks.
It's called the cross brace, and it's used to connect the front suspension system, and the two control arms will through the large hole, and it also have two screws to put to fix the arms and the cross brace. And for the control arm, I mill this part to fix the arm for the servo motors and connect the servo motors to control the arm flip up and down. And the last one is the block under the pan, and it's used to connect the pins for the middle wells.
I made the tank tracks. They're made out of bicycle chain, which we picked up for relatively cheap. And these cross members are made out of shelving brackets. And all the hardware was found down in the shop. So these tank treads, both sides only cost us about $12, and each track weighs in at just under 2 pounds. For our rear drive motors, we initially had continuous servo motors, but they gave us complications, so we ditched those and found these DC motors, and they run at a max RPM of 7,200. With the loading, their max RPM is roughly 5,200. So these motors provide the power we need. And then our front lift motors are servo motors, and they are currently giving us trouble, and they have a max torque of about 57 ounce inches, and we're looking at other avenues.
This is the layout for the wiring diagram for our robot. The robot will be running off of two batteries. We have one battery which is going to be directly controlling the MyRio, and then the second battery is going to be hooked into our DC motor driver. The DC motor driver can send pulse width modulation signals to each of our two DC motors that are on each side. The DC motor also has a 5-volt output, which will be used to power our servo controller motor. The servo controller motor will allow us to properly adjust both of our front servos to raise the front up when we have to initiate the first stair. The reason for using this DC motor controller is to properly code with pulse width modulation. The pulse width modulation through LabVIEW will allow us to individually control each wheel forward and back at incremental speeds depending on the duty cycle and frequency that we set accordingly for the robot. So it's not just going to be full on or full off.